Hello guys, welcome to next lesson of CCNA 200 of the 301 paper. Today our discussion will be on OSPF, all the concept of the OSPF theory and configuration. So first of all, we'll start about the theoretical of OSPF. If you have not subscribed the channel yet, kindly subscribe the channel. So let's start about the OSPF. OSPF Open Shortest Path First is one entire gateway protocol, so it have ability to work in one AS or it can communicate between different AS. Let AS it means autonomous system that many router can be consistent in one AS and OSPF can communicate in one AS. Like assume this one AS, this another router belongs to them, is another router belongs to 81 AS. This all is one AS, autonomous system. So another AS is there. So OSPF can communicate between different OS. For the selection of the paths, it will exchanging the package to get the destinations. For reaching the destination, assume the packet from this router want to reach to this router, it will select the least cost path. It means OSPF have the all topology of the network. It means that it have all information about the each router that's connected to this router. So it have the all topology of the network that they can select the base cost path to reach the destination. Let's discuss about the type of package which is used in OSPF. We have 5 packet types in OSPF. These 5 types of packet will be using for routing process. First packet is the hello packet. The hello packet is be using for when establishing and maintaining and adjusting between the routers. What does this mean? Let me explain in you here with the scenario. Assume that we have one router, OSPF is configured, and there is another router, OSPF is configured, here is another router. So first of all, this router want to establish the connection between each other. They will establish a connection by sending the hello packet, and it will maintain this connection also by hello package, and it will adjust about the bandwidth and etc by this hello packet. So another packet that we have is DBD. It means database distribution packet. Database distribution packet is contained an abbreviation of link state database. It means database distribution have the contents of the abbreviation of link state database that it will be sent from router A to router B. So DBD or database distribution package have the content of link state database. What is link state database? Link state database is content of active link which is connected to the router. It means the active package, active map, or all the map in our one router that is already current. We can say in one word current map of one router that will be created by LSA link state advertisement. So we can say that DBD have the content of what? Database of link state. So database link state will be created by LSA. What is LSA? Will advertise the active links. That's they will create a map in one network. So by the LSA they will create the database of link state, so that DBD have the abbreviation or have the abbreviation of this link that it will send to the another router to show its current connection. So another package that we have is LSR, a link state request. When router A have been received uh, DVD from when router A has been sent a packet to router B, this router will be checked that's the DVD with their map. If this router require any more information, they will again send in to L by name. This package will be by name of LSR, link state request. It means it's requested to send me more information about your link states. So the next router, again this router will be reply with the LSU, link state update. So in LSU is the content of more information about the current link or update information is included. So when this router received the LSU, again this router replied the LSU acknowledgement that okay, I have received your current links. By this 5 package, the OSPF can adjust and they can process the routing between the routers. Some other thing that you need to know about the OSPF. OSPF will be using the router ID. The router ID is the originator router. What is router ID? Router ID is a unique number of a router. It's a unique number of one router. This one router A, router B, router C. Each router in OSPF have a unique router which is contained F32-bit of IP version 4. That each router can be specified by that unique ID, which is called the router ID. And another is the area which the package is originated. So what is this area mean? Area means the multiple router which is contained in one group of routing, which that's calling this area ID. Area ID, this router can just advertise its LSA package to or hello package to these routers, to this group of router. If we have another area here, so this router will not advertise this LSA to this area. It means a group of a router in one area, that's calling the area ID. Network mask, you know about the network mask. Hello interval is a number of a second between the sending routers hello. When hello is sent, another router will be waiting after some second. This waiting is calling hello interval. So about the router priority or designated router, backup designated router, will study more. This hello package have the following responsibility: discover OSPF neighbor and establishment neighbor adjacent, and advertise the parameter on the which two router must be agreed to become neighbors. So each router which each other by default they cannot become neighbor. They should have some parameter that we will speak about this. What are the parameters? The parameters of this, the parameter that we are talking about is the both routers should have the matching value, like about the hello interval, data interval, network type, and area ID. These 4 things should be matched with each other to become a neighbor. So another is electing DR and BDR on a multicast network such as Ethernet or frame relay. So what is DR and what is BDR? Why we require it? So as you know that LSA is flooding to introduce its current link state to their neighbors. Or in this scenario, in multicast network, while LSA is flooding, it will create multiple adjacents with one adjacent in between pair routers, and it will extensive flooding of LSA. In this case, the router will become more traffic on one router, and it will become unmanageable, or it will be create the problem like multiple adjacents on pair router and extensive flooding of LSA. So they created the DR and BDR to manage this traffic. In They created the DR to reduce amount of traffic on multicast network. They will they will elect one DR and one BDR. So the DR is responsibility for update all other OSPF router when the change occur in multicast routers. So the BDR will monitor the DR. When the DR take it down or failed, then the BDR become the DR. So other router will be D borders. D borders are the router which is not DR or not BDR. So OSPF will be using the algorithm of Dijkstra shortest path first. So this algorithm, how it will work. So when LSA is flooded or other router is receiving the LSA, all the LSA, they will create one database by name of link state database. So when this link state database has been created, they use the SPF algorithm to create one SPF tree. By this tree, they will calculate. By this tree, they have all the map of the network, so they can calculate the cost of each path. So for from the source to destination, they can analyze the cost of each path. The shortest cost will be selected the base route in OSPF. The cost will be used bandwidth in OSPF. Cost is equal bandwidth. So this cost have a formula in OSPF. Cost is equal to hand rate per bandwidth of the link. This bandwidth will be in MB. So by this they can calculate you can calculate the each path of the OSPF. So OSPF have one thing we can communicate as the first, as I had told you, OSPF can work with multiple area. So why we require multiple area? When the number of our routers getting increased, then we require it to have multiple area. If we don't create multiple area, the routing table become too much large, and when the routing table become large, we will have the large of LSDB database. So the convergence speed become too much less, and the calculating of the path cost has also become too much hard. It will reduce too much CPU processing and etc. It will create too much problem for us. So in this case, if our router become a lot, we require it multiple area. We will require to divide the router in multiple area. Multiple area will be designed. In multiple area, we have same topology that we have some internal routers. So and all internal router will be connected to area border routers and the second area is the same area border routers. So all of these area will be connected to backbone routers. So the multiple area improve the performance of convergence and working very fast in the network. Okay, let's configure OSPF in a single area. Then we will configure OSPF in multiple area. First of all, we'll choose one router, open router, we'll adding, sorry. First of all, we need to off this router. We'll add, yes, we'll add the port, yes, we can make it on this router. We'll use 3 router to create the OSPF, yes. Okay, we will join this router using the serial, yes. I will assign IP address to each port. Then I have just configured the IP to this 3 router. Let's configure the OSPF. First of all, when we enter a router, we need to add the process ID, router OSPF. This is the process ID. The process ID will be selected from 1 up to 65,535. This process ID can be unique and uh, can be different between these routers. It will be represent from the processing of the which interfaces belongs to that. In OSPF we can use different process ID, but in EIGRP the process ID should be the same. So in OSPF also we can use the same process ID. Let's say in this configuration we will use the same process ID. Router OSPF will use process ID 10. The next step, you need to identify the router ID. As we had told you that the router ID should be unique for each router because it will represent or identify each router. So router ID will be 1111. Yes, it can be 111. Yes. If you not specify the router ID, the highest IP address of the IP of the the highest active IP address will be selected as a router ID. If we have a loopback address configured in a router, then the highest loopback will be as a router ID. So next we need to identify the network. The network we need to identify both the network. Then 0, 0, 0. Then the wildcard mask, we need to identify the wildcard mask. Yes. After the wildcard mask, we need to identify the area, which area is belongs. We will select this should be the area 0. Yes, this has been done. Next network, we'll select another. This network will select 11.0.0.0. We'll select the wildcard masks 255.255. The area should be area 0. Yes, DoodleDR. This router has been configured. Let's configure another router. First, the process router OSPF 10 router ID should be 222. Yes. Next, we need to specify the network. This network should be 11.0.0. Wildcard mask. Yes, this is a wildcard mask. Area should be 0. Yes. Then another side. Yeah. This router has been done. Let's configure the last router. Router OSPF plus ID 10. Router ID should be 3. Yes. Network 12.0. Wildcard mask. Yes, area should be 0. Yes, same to that network is. Do WR exit. Thank you so much for today's lesson. Kindly subscribe the YouTube channel. If you have any question, you can comment in a below of video. If you require the material, you can ask in the comment.